So all this taken together is that the future really holds one thing for sure, that escalating flood losses are to be expected, and that's a fact. And when I say expected flood losses, I don't mean only the economic losses, that can also be losses of life. And if anybody says, well, you know, it couldn't happen here, it can. The fact that New Orleans lost 1,500 citizens, that was in a country that is extremely developed, where they have hurricane warning systems that tell them 3 days ahead where the hurricane is going to go, and yet they lost 1,500 lives. A flood that would lead to a dike breach long before overtopping of the dikes on Fraser River, for example, could easily kill a few thousand people. You may say, no way, of course, unless the people are evacuated, and the dike breach can happen before the evacuation orders are given, and it happens at night. These spring floods are cold. In portions of the Fraser River, flood inundation isn't going to be half a meter. In the area of Greendale, near Chilliwack, flood depths will be 8 meters. Even if you climb to the attic of your house, you're going to die. So we're not talking about a trivial issue here. So why do we need to change? Well, flood risk is a moving target. BC's population is changing. And if you look at Vancouver and the surrounding areas, as you look at the Okanagan, for example, it is changing pretty rapidly. Vancouver, if you're not really careful, is going to turn into another Los Angeles basin. And where do people go? Very few people will build their houses on the ocean. Nobody in their right mind, not normal people like myself, can afford a place in Vancouver within a 10 kilometer diameter of downtown, where the cheapest building costs $1.5 million. So where is it going to go? Well, it's going to go in the Fraser River floodplain. We have about 350,000 people living there now. In 2050, it may be 700, 800,000, or maybe 1 million people living on the floodplain, all subject to flooding. Flood frequency analysis is flawed in many cases, and I'll get on with that in just a minute. A hazard-based approach, and that's so fundamentally important, neglects the consequences. And the consequences are, for example, loss of life. If you design your flood mitigation for a 200-year flood, and you say, that's what I'm going to do, well, that's fine if you keep the population numbers exactly the same, the potential damage to the infrastructure exactly the same, but you're not. Take again the Fraser River, I'm going back to that because I know it well and because it is rather important to the BC economy. You have the basic infrastructure arteries running through there, be it the Kinder Morgan oil pipeline, be it the Terrace and gas pipeline, be it the Trans-Canada Highway, be it the Canadian Pacific, the Canadian National Railway, be it telecommunication lines. Everything goes through that corridor. A very large flood can take that out, can sever that artery, and slowly let BC bleed. BC's current flood management approach cannot prevent and inadequately limits catastrophic loss, because really, realistically, if you increase the infrastructure, if you increase the number of people that live on the floodplain, you must increase your design standards. In other words, if you go from 200 to 400,000 people, you better go from a 200-year flood design to a 500-year return period flood design, or something to compensate for that change in potential consequences. That is not being done. It is not being addressed at all. So I was talking about flaws in flood frequency analysis. This goes a bit into science, so I'm not going to dwell on it. But the statistical method that hydrologists are using to determine these flood frequencies, they have a few caveats that can be put into nouns. One is called homogeneity, one is called stationarity, independence, and randomness. Big words. What they mean is the following. I'm not going to get into all of them, but two are important to highlight. One is stationarity. What that means is if you have a data series that goes bump, 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 but doesn't change over time, that's stationary. The long-term mean of the data series doesn't change, be it peak discharge or be it flood volume. As soon as you have a change in the trend, be it up or be it down, the data series is called non-stationarity. Your traditional statistics that are being used in flood frequency analysis do no longer work. With climate change, we are increasingly seeing in the province this phenomenon of non-stationarity, where we have trends in the data series and simply the statistics that are being used do not longer work. They give you false results. Same as the notion of homogeneity. We always, mostly the data series is taken, the maximum annual flood, for example, and then the statistics are run on that. Who says that the same hydroclimatic event produces the same flood? If it's different hydroclimatic events, meaning rather than rain, it could be rain on snow, rather than snow melt alone, it could be that rain on snow through the convective heat transfer adds a lot more water to the system. These are distinct data population. They ought to be analyzed differently. What you see there, these different curves, are a few rivers in British Columbia that if you look at the entire data sequence or you break it apart in these different hydroclimatic causes, you will come up with very, very different results. That needs to be acknowledged. The other part here, this curve, shows very much, it depends very, very much on how long your data record is and in what period it was taken in order to make your extrapolations. BC, unlike, say, the Nile River, or unlike the Rhine River in Germany that has hundreds and hundreds of years of gauged records, often there's only 10, 20, 30 or 50 years of data. Now if you take a 30-year data record and you extrapolate it to 200-year return period, of course you create huge uncertainties, but typically only the mean value is reported. What should be reported should be the prediction, so-called confidence interval. So also you have in the Pacific, you have undulations of climate, natural undulations. I'm not talking about human climate change. You have these so-called ENSO, El Nino Southern Oscillation periods, a cyclicity that occurs every 5 to 7 years. You've probably heard it in the news. When we have a La Nina, which is the opposite, it rains more in BC. If we have an El Nino, it rains less, or snows less. We also have the so-called Pacific Decadal Oscillation, which has a wavelength of approximately 20 to 25 years. This really changes dramatically the hydroclimate in this area. So if you have a PDO, Pacific Decadal Oscillation cycle of 50 years, you have one cold phase and one warm phase. That doesn't give you the answers yet, but it has a strong non-linearity associated with it. Then you have things like landslides, very large landslide. The landslide you see behind me is a rock avalanche / debris flow that occurred half a year ago on Mount Meager, a quaternary volcano in the background that had its last eruption 2,500 years ago. Interestingly enough, in the local language of the Mount Currie Band, the mountain is called the mountain that spits fire, illustrating the oral history of that area that goes back at least 2,500 years. On August 6th, there was a very large landslide that came from the peak in the center top and fluidized, reached velocities of over 300 kilometers an hour and dumped 40 million cubic meters of material onto the Lillooet River floodplain. 40 million cubic meters would fill a train from Vancouver to Halifax, no problem. It's a lot of dirt. This pile of dirt changes the river, the fluvial geomorphology dramatically. I like, of course, using dramatic examples because they're the most illustrative one, but something like that can be transferred to your watershed, to the Salmon River watershed as well. Widespread logging, widespread beetle infestations, forest fires, they all change the hydrology in one way or another. Sometimes it's very difficult to quantify just how, but they do change things. Floodplain development can also change flood hydrology. In this particular case, the initial worry was that Meager Creek, which is the creek that goes off to the left there, was dammed by the landslide, and the worry was that the landslide dam would breach, and definitely would breach because eventually it will be overtopped, and this is not a constructed dam, that it could create an outbreak flood wave that would exceed the 200-year design standard for the river. Because the landslide was so fluid and the landslide dam was low, it did not breach catastrophically, and the flood wave ensuing was about a meter higher than the stage at the time. But now there is a bit of a latent problem in that you have 40 million cubic meters of material sitting on the floodplain. Not all used by the present channel, but this material will get integrated and dumped. Rivers pick up sediment and they dump it. And that dumping changes the river plan form, it changes the river cross-section, and with that it changes the stage of future floods. So Pemberton is well advised right now to remeasure their cross-sections and to determine how over time that may change the flood profile and how they can protect their town and the surrounding areas from future floods. Then we have these hyper-concentrated flows or debris flows that can also alter very drastically the fluvial geomorphology and the flood behavior of creeks. Here's a good example from Britannia in 1921 when a tailings dam gave away, it wasn't quite a tailings dam, but a man-made slope. It dammed the creek and caused this outbreak flood on Britannia Creek, which you can see on your drive from Vancouver to Squamish. 56 miners died in these barracks, and these before and after pictures illustrate that quite nicely. These are geomorphic processes that need to be accounted for when looking at rivers at different scales. We're not only worried about debris flows on watershed scales of 5 square kilometers or 1 square kilometers, but we're also interested in these much larger watersheds, such as Lillooet River that you've seen earlier, which has about a watershed of 2,500 square kilometers to 1,000 square kilometers larger than that of Salmon River. So I was talking about the consequences and the importance of risk assessments. Now the consequences of floods are manifold. We cannot just think of only economic losses. Let's start with loss of life. I've mentioned the important example of New Orleans, now superseded by an even more dramatic loss of life due to flooding, ocean flooding in Japan. Widespread destruction of homes, well, that's what the insurances are worried about, but there is no such thing as flood insurance for homeowners in Canada. In the US there is, in Europe there is also, not here. You can insure your industries against flooding, but not your private homes. You hope that PEP's going to bail you out. If you have a home that's more than 300,000, well, you pay. And widespread contamination, that's something not to be neglected. If you have on a floodplain chicken farms, manures, livestock that you can't evacuate, hazardous materials, paints, petrology product, all this gets entrained in the flood and adds to widespread contamination. Wells can't be used. It may take weeks or months for that to clear up. Dead animal bodies deteriorating. Economic loss through traffic interruptions, service interruptions, trade interruptions, loss of tourist dollars, insurance losses. We did an analysis like this for the city of Chilliwack, and it was unbelievably difficult to quantify all these individual factors. You may imagine that it's not just simply the loss of your house as it reaches a certain flood elevation. It's a write-off, and you have to reconstruct it from the start. It's your businesses that fail. It's the people that you have to lay off in order to reconstruct your business. It's maybe you lose the business altogether because your clients go to somebody else in a not flood-prone area and don't come back to you. It's those kind of losses that are almost impossible to quantify, but they all amount to something. Loss of fish and wildlife habitat. That is a consequence of a flood, but sometimes floods are also beneficial to recreating habitat. Floods are not always evil, floods are part of the normal ecosystem. Financial hardship for uninsured owners. Like I said, the provincial emergency program can bail out people to the billions, and the Canadian government may also say no, depending on their budget constraints. And then, of course, the issues of personal stress and grief. It's not to be neglected. It's not just saying, rats, I lost my house, well, I'll build a new one. For example, the 2005 floods in Great Britain led to an enormous increase in suicide rates. People were so stressed about having lost their homes, the traditional homes, be it the, injuries or death in their families, even though the death toll is very low, people do freak out about this, and rightly so, I would. And that is a variable that one cannot put into dollars. How can I put my stress into dollars? I can't. So we are gladly living in a society that can afford flood protection. We're not living in Haiti, we're not living in La Paz. You probably haven't even picked that up in the news, that 1,500 homes were destroyed last week by landslides in the capital of Bolivia. Nobody, or I think hardly anybody died, so it didn't make it into the news. Even though these areas I was involved in that were mapped as high risk and nothing is being done because the society there is A, tolerates a lot of risk, and B, cannot afford the necessary protection. We can, but the question is how much? And how, more importantly, are we going to arrive at the decision what we're going to protect and what we're not going to protect? And those decisions ought to be science-based. They shouldn't be haphazard, they shouldn't be purely political, they should be based on sound science. Only that gives you the tools in order to make the decision necessary to protect. So, I'm not going to go through very much detail in this